Dear students, I welcome you all for another video session on writing a HDL program. Okay, writing a HDL program or coding for D flip-flop. Okay, so students, as I've already discussed, to write a VHDL coding, we have to know the basic operation of a device, right? So we would have seen that in the combinational circuit. So let us code for the D flip-flop. So all of us know that in case of a D flip-flop, the most commonly or popular flip-flop, which has the speciality of whatever you have in the input exactly comes to the output, right? So that is what is the specialty of the D flip-flop. So the clock being high, so I can say that when the input is 0, my output goes to 0, right? When my output is 1, the output exactly is 1. That is the main feature of a D flip-flop. Now let us enter into writing the code for the HDL code for D flip-flop. So we would have seen in our previous video sessions how to write coding for the SR flip-flop. Similarly, let us follow the steps for the D flip-flop. Okay, so starting with library IEEE. So let me declare the functions or call the functions. IEEE standard logic 1164 all entity. The hardware which I am going to code is D flip-flop. So within the port, so let me declare my inputs and the outputs. So D clock and reset. Okay, so reset, if I need, I can mention it as clear also. So these are my inputs, right? So these are my standard inputs. And coming to the output, so Q is my output. So I'm declaring this within the ports. Okay, now end D flip-flop. So the architecture, next is architecture. I've named as D flip-flop as begin. So let me begin the process as we usually do with the inputs, right? D, clock and reset. So let me begin the process. So the condition is, you can just concentrate here. If my reset is 1, then my output is equal to 0. Dear students, we very well know that when the reset is high, the flip-flop output just goes to 0, right? We know that. So that is what I have written here. Okay. Else if rising edge, clock, then, so I'll write here, that is whenever the clock has the rising edge, the input will be equal to output. So these are the two conditions which I am mentioning here. So once when the reset is high, then my output will be equal to my output will be equal to 0. The next condition, else if the rising edge is, if the clock has the rising edge, then the input will be equal to the output. Okay, so let us write that. So Q is equal to output. The output is equal to input. Okay, so let me end the process. End if, end process, and end D flip-flop. So dear students, so basically we have just included our inputs, that is D, clock and reset, and our only output Q, and we know the function of the D flip-flop. Whenever the input is 0, the output is 0. Whenever the input is 1, the output is 1, right? So we have just begin the process including our inputs, which is very crucial for the operation to occur. So based on the two conditions, if reset is 1, then we know that the output will be equal to 0. Else if when the rising condition is clock, that is if the clock has the rising edge, then the input will be equal to output. That is, the Q is equal to input. So end of N process and NT flip-flop. Dear students, hope you have understood the VHDL coding for D flip-flop. You can revert back to me for any doubts. Thank you.